Hey, let's rock. 2017 Exam 2. Let me pop those in the chat for a download. As always, we shall start off with the external response. Like they've been sent now. Yep, okay. Screen shares up. Awesome. Okay. Question 1. We got some sort of cubic. Find the coordinates of the turning points. This is exam 2, so tech active.
I got 15 root 3 and negative 10 root 15 all over 9. And then negative root 15 on 3, 10 root 15, 9.
Yeah, those are good. Good thing you gave both the coordinates there, and just knowing which one's paired to what. The minus goes with the plus goes with the minus. Nice. Nice and quick too. Part B. So coordinates at x equals -1, x equals +1. Find the equation of the straight line that connects those 2 points.
Is it y is equal to negative 4x?
Y is equal to -4x. Yeah, that's it. Assuming you got gradient by doing the rise of a run and then probably a y equals mx plus c, or
Yeah.
yeah, okay. Sweet. Next up, distance between those 2 points. That'll be very chill.
Root 68?
Yeah, you can go simpler though.
Yeah, simple. Let me see. 2 root 17?
2 root 17. Yeah. Nice. Part C, we have a new function, kind of, just replacing one of the coefficients with k. Same points on the graph, well, at least the same x location. Again, finding distance, but this time it's going to be in terms of k. As a quick tip, just in case you haven't already done it, make sure there's a multiplication sign between the k and the x. Otherwise the Kaz will think it's called kx. That might be slowing you down.
No, this I was doing it tech free because I was
Oh,
getting my CADs out. Yeah, I've got my
oh,
CAD.
sure,
Okay.
sure. Well, that's pretty. Hang on, you were doing all these tech free? Damn, nice.
I just had my school maths exam today.
Oh yeah, how was that?
It's pretty fun. It was pretty okay, I think. Yeah.
Yeah, I'd imagine so. You've well and truly surpassed where you're currently at, or where the school's currently at anyway. We're still in victory laps now, aren't we?
Okay, so I got two
Hmm.
root k squared minus 2k plus 2.
Crushed it. Yeah, same thing. Nothing really different there. Obviously, we just use the CAS to aid us in the simplification. Yeah, very chill. Nice. Find the values of k such that that distance is now going to be equal to k plus 1. This looks like it should be chill, but I'm a bit suspicious of it. Maybe it will be fine though. Yeah, okay, that's fine.
Is it when k is 1 or 7 on 3?
Yeah, yeah, that was very chill. I did just take a look at the exam report afterwards. 62% pass rate on that one.
Are people just overthinking or are they like just
Maybe.
not applying it?
I mean, because I'll say when I looked at it, I was like, huh, that's a bit suspicious. I feel like that's really really easy. It is 1 mark, um, but yeah, weird. Let's have a look. What are the actual? Oh, here it is. Um, some only gave one value for k. Um, oh, well, like yeah, no, I guess it's because of consequential, right? You need this result before to actually answer it. So yeah, that's why. Because if you have a look
Did
at the
they like
mark.
not give consequential marks in methods or?
Well, I mean, yes, but what can you even do there? Like, if you don't have an equation for this, you can't really just make one up and then do this. Um,
No, but say if someone had like the wrong equation for distance.
hmm, someone got this wrong, then this. I mean, you might just flat out like have no solution. Like, let's say we got, I don't know, hypothetically, it could be like a +3 instead of a +2. Now, obviously, there's going to be a reason why there's a different answer, but like sometimes you'll just get false if it's not good enough of an answer. Um, and so if you make a mistake, it's potentially quite likely that when you do CAS solve that, you just get nothing and you're kind of shit out of luck. Um, the statistics at least seem to indicate that only people that scored 2 marks had a shot at solving this one because you've gone from
Yeah.
64 down to 63.
How come on question 1CI, the percentage adds up to 101?
That's kind of funny. Yeah, okay. That's funny.
I don't know that the examiner's doing the questions as well.
Um, could potentially just be a rounding error. That's, yeah, non intentional. Good pick. Good pick. Anyway. Yeah, imagine, because, like, obviously you're not going to get these round numbers as your actual thing. There's some number of decimal places behind those. But cool. Okay. That's double I. Part D. Find A in terms of K, where A is the intersection, or the second intersection point between g of x and y equals x. That should also be relatively straightforward. Yes, this is what I thought might have happened in double I, where you get a seemingly obvious approach, but what the CAS spits out's a bit weird.
Yeah, there's like a few solutions with like different,
Mm.
like K has to be like a different value.
Yeah, right. So K is told to us it has some condition on it there
Ah,
that
I
can
see.
help you restrict what's going on. Also, the location of it on the graph helps a lot. You can see A's in the first quadrant, so that can already limit the possibilities that you're seeing on the CAS.
Right. Okay, so I got root K plus 1
Yeah,
and root 2.
and root 2.
Oh, sorry, no, never mind, never mind, my bad.
Just root K plus 1?
Yeah, just root K plus
Yeah.
1.
I tried to mess around with it a bit to see if I could eliminate all the other issues by maybe putting the condition of k being greater than 0. It still kind of does the same thing. So you've pretty much just got to scroll through, or my preference rather than scrolling through it all is actually just grab a copy because that automatically puts you to the end of the list there. Now, I believe that does come with an issue, which is if this is too large, you may actually miss a third solution that's sitting there in the middle somewhere, which doesn't appear to be the case here. Yeah, no. But if it's sufficiently large, you might miss it. But that usually helps for the vast majority of cases. Um, cool. Okay, that's that. Double I, find the area of the shaded region. Couple of ways you can go about this. Um, yeah, this should be fair enough. Good news is you're being awarded 2 marks for what's effectively 1 line of effort, or at least it could be 1 line of effort.
One?
Shouldn't get a single value. It should be in
Yeah,
terms
that's
of
what
k.
I'm like confused about. For some reason I've got a single value.
Okay, that's interesting. Um, did k ever get defined as a number?
Ooh,
If you just type k in the CAS, do you get a number out of it?
I don't think so.
So if you just press k, it shoots back out k.
No, it shoots back one. One.
Okay, well then clear variable of k. Um, so go through menu 1, 3, delete variable, and then put
Okay,
k there. That should fix it.
let's try that again then. K plus 1
Yeah,
all squared all over 4.
there you go. So that's a bit strange. K was already defined. I wonder why that didn't matter for. Well, hang on. Did you do CI? Oh, you did it by hand. Then that's why. It was only in double I where you cased it. Is that right?
Um, yeah,
Yeah. Okay. That's why it didn't come up. And this one, I mean, well, even then, maybe you just put X in the cas instead of K for that.
yeah, I'm not too sure. Let me
Yeah.
just check.
Anyway, either way, if you get a constant value, probably pays to just double check. Hey, did any of my variables accidentally get assigned something? Especially when it says in terms of k, that guarantees that you need a k in your equation. Okay, Ferris wheel, height of the wheel at any given point from the particular carriage is given by h of t. State the min and max heights. That'll be easy enough.
I'm gonna do a little bit defining right now.
Yeah,
I
yeah,
think
same.
the answer is 10 and 110, but
10 and 110.
oh,
Yes.
10 and is it? Oh, I thought it was 120 maybe.
Oh, sorry. Oh, yeah. No, you were at 120.
120.
I also did a quick math error. Yeah, 10, 120. And yeah, making sure you're putting those as meters is good. That's a strange phrasing. For how much time is Semi in the capsule? How much
For,
time?
for one complete rotation of the Ferris wheel. Oh, it's just period.
Yeah.
Is it 30 minutes?
It is 30 minutes. Yeah. That's good. Just basic old 2 pi on n. Rate of change of h with respect to t, and hence state the value of t for which the rate of change is a maximum.
Ooh.
That's fun.
Rate of change as in diff?
Yeah, so h with respect to t pretty much guarantees you're doing diff of h with respect to t. Yeah,
Okay.
that's definitely going to be one part of it.
And hence state the value of t at which the rate of change of h is at its maximum. So then when you get that diff, you want to look at its turning points, I guess, and
Yeah, look at the diff's turning points. Yes.
right. Uh-oh. General solution.
Yep. Circular functions always come across a general solution, unless you do something about it.
Restricted domain.
Yeah, restricting domain.
Uh, 15 over 2.
15 over 2. Yeah, a couple of ways you could have done that. Probably did you diff and then diff equals 0, or did you diff and then f max the diff?
Define diff with the domain and then fmax.
Yeah, okay, cool. F max is probably a nice way to go about it, because usually when you do diff and diff equals 0, you kind of feel like you've already done a diff, so you forget to do the second diff.
Yeah.
The other
Now
thing,
also like you get so many points. It's so like
Yeah.
stuff like
Oh, true.
vector
Yeah.
functions.
Yeah, you
Or
get a
I
lot.
guess unless you were to restrict it to like specific domains.
Yeah. Yeah, I mean, anytime you're working with circular functions, you pretty much need a restricted domain. One of the things I like to do if I'm even if I am kind of on point, like we kind of calculated the period earlier, we knew what a good domain would have been, but even so, I still just sort of put it on the graph and just see, okay, cool. At least now I know, yep, there's my max. So if I get numbers that don't look anything like 7.5, I know I should fix up whatever I've just done.
Yeah.
It's I don't know, just a bit of peace of mind. Oh, I remember these getting a bit interesting, although it's been a while, so maybe I'm just
B.
going to theta, where theta's there.
Oh, this is with reference to the old one, right? With the old Ferris wheel.
Yeah, so we got this Ferris wheel. Um, we got this thing of h of t, which tells you the height from ground. So ground is still considered like where that origin is, effectively. Um, so we're still going to be probably requiring something to do with that h of t there.
Okay, so from C to O, I think it's 65.
C to O, yeah, because that's the center.
Yeah.
So 65, there's your center line. Yep.
So that should just be tan theta is equal to 65 on 500, right?
Opposite over adjacent. Yeah, that sounds good.
Let me just do that real quick. Oh, still in radians.
Yeah,
Well, should be 7.41 degrees.
7.41 degrees is correct. Yeah. Which is good. That's a 36% pass rate one there. As soon as things start getting into trig, people tend to start getting a bit confused. Even the pass question that we just did, 2C, that was 29% pass rate there.
Yeah. This is probably one of the, I would say, easier exams, but I haven't seen any probability yet, so
Yeah, I mean, it's
yeah.
been chill. Question one's usually decently easy. Question two might step it up a little bit. Question three's probably going to be some probability stuff.
What the part
Let's have
of
a look.
P is
Yeah. Oh, yeah, it was.
what
Anyway,
the part of P is given by y is equal to
that's a fun one. The first part of that's obviously whatever, although still not 100% pass rate, which is always sad to see.
okay. I'm just gonna try and do that without a domain on that.
Yeah, that's probably more appropriate. I would only ever really chuck domains in when I'm specifically doing cas solves. I don't know, I just sort of tend to do that. It also might be the case that this function just naturally has that as its maximal domain anyway. This is a semicircle.
No, I mean you get the same answer even when you have domain. It just puts like this like weird like little branch looking thing on the left, and then
Oh yeah,
yeah, it's
it's
negative x all over root 3025 minus x squared.
yeah. I'm not getting that, which is odd. I wonder what you've got going on differently.
like I defined a function, like as this one,
Yeah.
y is equal to root 3025 minus x squared plus 65, and then what's it called? Then I ch also put the domain in the define, and then when I did diff, it like had some like weird looking
Okay, yeah.
in there.
Yeah,
Yeah,
that's what's going to happen if you have a domain with it. I thought you said you took it off.
yeah. No, when I did have the domain on it, it had this little branch.
Yeah, that does that. Yeah, whenever you got a domain, and that's kind of why I don't like having it on there because it makes it harder to work with afterwards. Like for
Mhm.
instance, it's harder for you to grab a copy of it. You got to strip off all the other shit to
Yeah,
work with it properly. But okay, at some point it becomes no longer visible, or the boat rather becomes no longer visible. Find a gradient of the line segment from point P2, whatever that is, connecting B.
E2 UNV. Yeah, let me read this. Angle OB E2 is equal to A. Yeah, so if it's tangent, we just want to find the diff of that function at U, right?
Yeah, diff of diff of what function? The
The Ferris wheel,
so
but that wouldn't
the
help
Ferris
me.
wheel equation itself at the very beginning, that was about where its vertical height was, which is probably why you said it won't help that much. We do have another equation though, the path. So this path equation basically is the equation that describes, well, technically describes up here, I believe. I think it's the top of the, is it top of? Yeah, it's got to be the top of the semicircle there. It's plus 65 and positive root. And so for that reason, you would be using that because it's going to be describing that top part. That's the whole, and again, using some context clues, right? We found diff earlier of that function just randomly. Oh, cool. Tangent probably got to do with that diff that we just found. Um, and so the first mark of this is literally just going to be replacing the x's with u's
Right, so
because,
negative U all over root 3025 minus U squared.
yeah, yeah, it's going to be a start. Hence, finding the coordinates of P2, however, is another story. Because now we have a new angle. We do have this right angle up here that's worth highlighting. Those are always helpful to understand. Or at least helpful to notice. Right angles are always associated with a few key features, one of which is probably quite relevant.
Is it angle A?
Well, angle A over
That's
there,
changing anyways.
that's a different angle, right? Because we had theta before, that was a shallower thing. We had angle alpha A, which is a steeper one. Um, we don't really have that same trick available to us, at least yet, because this opposite side of the triangle isn't known, or at least not fully known. We can get up to C, we could even get up to the top of the circle, but that line does go above the location of the circle. Um, this right angle, a couple of things you can do with that. Um, one is you can potentially create your own separate triangle connecting C to B, That might help in some way, shape, or form because you have a right angle triangle, you've got SOHCAHTOA, you've got a lot of good stuff that you might be interested in. However, the approach that I'm personally going to explore would be when you have right angles, that's related to normal line stuff. And I feel like that's probably a better lead to follow because we've got diff stuff. Um, it ties closer to diff by following that. So I would start saying, okay, well, if the gradient of the tangent is negative u over the square root of all that stuff, then the gradient of the line connecting C and P2, that is going to be negative 1 divided by all of that stuff because you're flipping it. We know the location of C, so that could give us an equation of that line, or at least get us closer to an equation of that line. It's starting to get us closer to solving P2. I haven't fully crystallized what that's got to look like yet, but that'd be the lead I'm going to be following.
I mean, I've got the line of the normal,
Oh, you do?
but yeah, I'm not really sure what to do with it after that.
Okay. Well, if you have the line of the normal, that means you have that dotted line. Now, I want to find this coordinate. Um, this coordinate is associated with a whole bunch of different lines. It's associated with the normal line, it's associated with the tangent line, it's associated with the circle. So when we think about how we solve for points, normally, what kinds of things come to mind now that we understand that that point belongs to a lot of different equations?
Simultaneous equations.
Yeah, basically simultaneous, right? Make equation 1 equal equation 2, solve for, well, whatever we're trying to solve for. This is getting it in terms of u, so we don't need everything to be cancelled out, or at least, yeah, cancelled out is the right word for that. Or maybe it does. It does say 2 decimal places. Maybe it does all cancel out. But yeah, whatever you had your equation of the normal line there, the only equation that we do have left over is the path equation, which you can, like, the u doesn't really matter here. You can replace that with x, because u is just supposed to be some coordinate, or some x coordinate, rather. Um, that should be enough. You would figure out what the x coordinate is, and then getting the y should be relatively simple to follow up with. 8% pass rate. Nice. Well, that's kind of cool. The answers did it in a different way. We'll explore that afterwards.
Yeah, I'm a little bit stuck.
Bit stuck. Okay. Um, what'd you have for your normal line equation?
Root 3025 minus x squared all over x.
Oh, that's just the gradient.
And then you need to find a thing. Y-intercept.
Yeah,
Would that be plus 65?
yeah, plus 65 on it. Okay. Was that missing from your equation?
Yeah, it was.
Okay, well that's probably why then. Because yeah, it's plus 65 because you can clearly see the y-intercept is cutting through its c, and 65 was the location of that. So grabbing that, plus 65 is equal to, I think I call this y. Let's find out. Oh, wait, y of x, I need to replace that as u. Fail to click the u. Actually, no, I didn't fail to click it. It's my keyboard that's a bit sensitive. Yeah, okay. Why is that off? Oh, it's times u. That's the gradient. Times u. Again. Why's my u key so busted? Wait, how'd that happen? Generic normal line is equal to that. Why did that happen? This, replace, -1 over, and then the y equals mx plus c, the normal, equal to, well, I guess let's just figure out what y of u actually is. Did I do that right? Oh, because that's curious. I wonder why it does that. Hmm. Yeah, okay. That's interesting. Anyway, in this particular circumstance, they came out to be the same thing, which is very strange, or at least unlikely. So I guess the next best thing to do would be to do what they did in the answer, which is rather than go through, grab a normal and equate it to the curve, um, what you do instead is a simultaneous between the rise of a run version of calculating gradient and the diff version of calculating gradient. So if we have a look at what's going on over here, we saw earlier that the gradient was given, we could just chuck in the u, right, to get the diff version of gradient. This bit over here is a rise or run version of that gradient. And how you do that is to know, oh, we actually do know the coordinate of b. It's 500 across and 0 up. So we have the coordinate 500 comma 0. We have the coordinate u comma v, or really u comma f of u. And that gets you the other two spots. You can do a simultaneous between the rise or run version and the diff version. Solving that for you is going to give you, well, all of these, only one of which is going to make any amount of sense. Oh, sorry, no, that's both. Never mind. That's u and then that's v. Okay. Yeah, trickier. That wasn't supernatural for me to consider a rise or run version. Is it fair enough, at least conceptually, why that works?
Yeah.
Yeah, now it's just a matter of like, how do you identify that that's what you do in this circumstance? Um, it is a bit sneaky over here. I guess whenever you're getting equations for gradient and straight lines are involved, there's always going to be some form of ability to create a rise or run version of that same gradient. It's a pretty common strategy to employ. However, using it in this case wasn't super natural to me, but I guess the hallmark for what you're looking for there would be, hey, there's a straight line here, it's tangent. Can I potentially know that other coordinate? If so, cool. Rise or run. And that gets you the second version of gradient. Cheeky. Was that a question, sorry?
No, I'm looking at G now.
Oh yeah, cool. Once you
Can
have that,
we
that's chill.
just do tan theta is equal to the gradient that we got, and then solve?
We didn't quite get a gradient actually. We can get a gradient because we got the coordinate of these. We got two versions of rules for the gradient. Now that we have a specific point, we can then, yeah, go through and shove in the u and the v as what they were. Um, and then, yeah, tan inverse on, yeah, tan inverse, because we're looking for gradient, degrees, yeah.
Could you just repeat that again? You sort of cut out.
Oh, I cut out. Um, what was I saying? Yeah, so we didn't have an actual gradient yet, so we can't immediately jump into that. But because we do now know this point, we can get the gradient quite easily. We've got a diff equation. We just sub in, oh, I knew my value of u was this, and so f dash of u is therefore the gradient, and then tan inverse on that to get your gradient. Yeah, the angle. Any trouble with that?
Yeah, a little bit.
A little bit. Okay. I mean, it probably doesn't help that we didn't actually do this on the CAS. We just kind of looked at it because you do need these answers. Um, do you have these in the CAS yet?
No, no, right. I don't have them.
Yeah. So just pop this solve in the CAS to get the U. That's the actual only one that's important there. Just let me know when you got that.
And we were meant to was it meant to round to two decimal places, right?
Yeah, two decimal places. Now that's rounding when you give the answer, not when you chug it into the CAS for your other answer. Like as in, that's what you give for the answer to part F, but when you go and solve G, you don't use the rounded version.
Okay.
So at this point, you could have both coordinates, but you only really need the x simply because that's how diff works. You don't really care for y there. You've got two expressions for gradient there. You've got the left and the right. One of them's a diff, one of them's a rise or a run. They're both equivalent. And both of them only have u's in it. So whichever one you want to use, just plug in that value of u into those spots, and that will give you the gradient for that line.
Yeah. Is it 13.66? Oh, one off.
Did you put the rounded version in or the?
No, I did just rounding error for my end AS.
Yeah. Okay. Oh, sure. Right. Understood. Yeah, you can see in this case they used the diff. Wait, hang on, did they?
It uses a
Supposed to be.
normal, I think. This is a normal line function,
Huh. Yeah. Okay.
I think.
I mean, it looks the same as that, but they got the negative off of it. Oh right, yeah, of course. Because if you just do tan inverse with a negative there, you get the angle that's below the x-axis. Right. Okay. So you need to knock that off. That's why.
7% pass rate down.
Yeah. I mean that one is
Yeah.
actually higher than I would expect because it's like to say anyone that got 2F right probably got 2G right. And you kind of need all this to like if you didn't get this stuff, then there's not much chance. In fact, there's zero chance of you getting this because you need that U value.
Yeah.
That one's actually not too bad. It's F that was the killer.
It's find going to time to the nearest individual which the god at B is something.
That's an interesting one. The prescribed answers in the exam solutions is almost a bit spesh math. Um, so I've got a different way that I think will work. I'm gonna follow that one first, and that should be a bit more methodsy.
Yeah, I was about to say 26 minutes.
26 minutes is a little bit big. So I guess let's just be clear on what the target is here. First becomes visible at point P1, last is visible at point P2, and so you're trying to find how long does it take to travel from P1 to P2. Is that clear enough what the goal was?
Yeah.
How'd you go about it?
Would you want to see that like so where P1 intersects with the graph of f of x? I mean,
Yeah,
well, there's the circle, and then obviously P2 as well, and then you want to see the difference between them.
time difference between them.
Yeah.
Yeah, so that poses a bit of a challenge because if we have a look at our equation, this one here anyway, that's a path equation. So the x is your horizontal distance and the y is your vertical distance. There's actually no time in there at all. However, we do have a time one over here, where we
Yeah.
have height and time. So that poses a bit of a challenge, where you don't necessarily want the full coordinates of P1 and P2. You actually just want their y values, because those y values do in fact transpose over to the h of t. And so if you get this v over here, which should come out to be, what is it, 118-ish, and then you get whatever the y coordinate of P1 is through whatever means you're using there, you could create the, well, actually, how are we going to get P1? Create the line. I mean, we had theta, just tan inverse to get your gradient, and then y cos mx plus c is sorted, because again, you've got the plus c there. Yeah, getting P1 shouldn't be too challenging, or at least the y value of it. You have your two y values, so you then grab those, equate those to the equation, solve for t in both instances, and then find the time difference. It's definitely a longer solution than what's in the answers, but I think it's more in line of what you do in methods. What they did here was kind of like doing arc length stuff, where they said, cool, we have theta, we have alpha, the angle difference between them you can calculate, and then you can, based off of that angle difference, get it as a fraction of the circle, and then multiply by what the period should be to get your minutes. It's very spesh mathy. Definitely works and definitely is faster, but I wouldn't have thought of doing that.
Percent pass rate down.
Yeah, this one, like, massive fall off. And it makes sense why. Although I feel like doing this, yes, it's going to take longer, but that shouldn't have been a massive leap if you were able to. I mean, if you're able to get F and G, I feel like this one's probably a bit more achievable than those two. Yeah. Are you working that out yourself, or do you want me to jump in as well?
No, I'll let you
Yeah,
jump in.
sure.
I don't remember the data from the very first
Yeah,
one.
sure.
It's such a long question.
Yeah, it's a lot. Cool. Okay, so that was me just catching up. I knew that I needed my y value of that spot instead, so I grabbed the y value, and this is me getting my first time value. So there's actually two possibilities there. We're going to take the first. Actually, which one are we going to do? Yeah, the first time it reaches 118, because it's going in a counterclockwise motion, and so the first time would be at where P2 is. So I'd be taking the 13-minute one there. Then as for getting our P1, well, once again, as I said, we're just going to be doing the equation of the line BC. First we've got to get our theta off of that. So where was theta? Theta was 7.41. So that's that tan inverse. Find where that was. There we go. Cool. So that would be y equals mx. So we'll have, I'm going to call this one, I don't know, w. W is equal to mx plus c, which I believe, that was 65 or 55? 65.
65.
Yeah. 65. And then where does that... got to do something a bit cheeky here. P1 looks to be on the bottom half of the circle. Our equation here is top half. So you got to know a little bit to make sure you put a negative on that, so you'll actually get the cut through there. So that's getting a bit more closer to spesh math maybe. But anyway, okay. Let me just find my copy of that somewhere. It was this one. So I'm just going to redefine it. Go right over it. Where does Wx equal y of x? That's going to give me the... Nope, that's not good. What is... Oh, maybe the tan inverse is wrong. Maybe it's giving me the wrong thing there. That's better. I'd literally explained it before. When you do tan inverse, sometimes you get the opposite angle than what you want. That's going to give me that x value to get the corresponding y. It really doesn't matter which of these I put it into. That gives me that. And then finally, it was h. h of x is equal to that, comma x. Not forgetting to put a domain on that. Yeah, this is very involved. It's no wonder. Even if you do sort of know what you're doing, you might just run out of time on the way. And again, we're going to take the first of those options because we're going in a counterclockwise motion. The other one, there we go. Cool. So, I mean, we know what we're doing. You grab the actual thing, but I'm just going to do a quick subtraction here. 6.9-ish rounded up gives you the 7 that we were looking for. Obviously, you take the actual numbers there, not just do what I did by quick rounding, but yeah. Jeez. That's what I would have done. Obviously longer. Let's recap what that was. So, hence or otherwise, find the length of time. We already had this coordinate. We had to figure out what time we reached that. So we subbed in the y of that to get time with the ht equation. Then we had to solve P2, or P1 rather, by first getting this line off of theta. That's step 1, line off of theta. Step 2, equate it to a modified version of path P. Step 3, get the y coordinate. Step 4, sub that y coordinate into the h of t. Step 5, get the time differences from what we just calculated. Nice. Brilliant. That or... Yeah, okay. So basically, I think what they've done is they've just got the... where's the actual angle? They cast two... Let me see if I can draw this. Slightly a bit rusty on this, so let's see how we go. You got this. You've got a cast coming off of this bit, and you've got another line coming, not quite like that, like here-ish. And we had this angle, and we had this angle. What we wanted was... What specifically? I think we wanted this one. But they've done a 90 minus. That would have been 90 minus. Oh, yes, because 90 minus gives you this. So you want this in here, ultimately to get this, because that angle in there tells you how much of the circle have you passed through, right? It's the, whatever that angle is, it turned out to be 83-ish degrees. That's 83-ish degrees of a total of 360, which makes the entire circle. And if we're assuming that we pass through the circle at a uniform rate, 30 would be the entire thing. So what proportion is this? Well, it's the 83 that we just solved, divided by the 360 to get the fraction, multiplied by total time duration. Excuse me. That is a bit in special math where you do arc length stuff. Those sorts of equations come up there, but nominally to calculate this length in here, you can do a very similar thing where you say, "Yep, I got this angle. It's a fraction of a full circle. The circle has a circumference of whatever, so you multiply by circumference rather than time." Very similar concept.
Hey, damn.
Both options are quite tough. One is because you probably haven't seen much of this before, and the other is because you got literally 5 steps involved. So yeah, 2% pass rate, which also doesn't add up to 100. Nice, cool. Anything to clarify further there?
A lot, but let's
Well, I
move
mean,
on.
is there anything quick I could probably do for you?
No, like it's okay. I guess it's just practice with that stuff as well.
Yeah. Okay. Sure. So
And like
this
also
was
because you know how like say if you're in an actual exam, right?
yeah.
You would like you'd be writing down all your answers on the page, whereas here like we sort of just like going through them and I'm not really writing anything down. So then like
Hmm.
trying to look back and then draw on the answers that we got on the lot in the previous questions to answer like a current question is a little bit tougher than
Yeah. Then if you're in the actual thing, yeah, you're
yeah,
right. Having it there, especially in these neat little boxes, super easy to refer to. Absolutely. Um, and you can also see like what happens in a real exam as well. Like
yeah,
there's a lot. People panic, and then you just sort of. It's not even panic actually. You probably just skip it and do the next thing. Like when would I have skipped? At what point did this start getting weird? These were chill. This was sort of whatever. That's easy. You probably skip around here, and then you go to the next thing to maximize time efficiency.
yeah,
Easy. All right. If you have anything coming up that if you're working on this, this was 2017. You should already have a copy of that in the chat. If you're still working on those in your own time and there's still things to be clarified, just let me know and we can go through those. Otherwise, it's probability, I guess. Next class.
yeah. See ya.
So
Wait,
yeah.
damn. Two questions in the whole class. Damn. Okay.
Well, I mean, it's two extended response questions.
Yeah. No, it's like it's more like 10, 12 questions if you think about it,
Yeah,
but
it's so many marks.
yeah. Yeah,
Take
all right.
care.
See ya.